All right, so we're going to use what we've learned about single replacement reactions, and we're going to use these reactants to help us predict what those products are likely to be. In the case of the aluminum oxide reacting with our hydrogen, we've got hydrogen is our element, and hydrogen, he's a tricky one because we know that he can act both as a metal and as a non-metal. So we're going to have to make a decision, who do we want him to behave like? Because he's typically found on the metal side, I'm going to treat him as a metal. So I'm going to say he's going to be a metal. And so the cation that he's going to make is going to be the hydrogen positive ion. Now, that means he's going to take the place of my aluminum. So that aluminum is going to go on his own as my new element. And I'm going to have my hydrogen is going to pair up with my oxide ion. And when I do my crisscross, that means I need to have 2 hydrogens for 1 oxygen. Or in other words, I've got water. Now, when it comes to my balancing, I'm going to be balancing the same way that I have been before. So it doesn't matter who I start with. I typically like starting with oxygen if I see oxygen there, just because oxygen can be a tricky guy to balance. And so when I take a look at my oxygen, I've got 3 oxygen on my reactant side, and I've got 1 oxygen on my product side. So I'm going to put a coefficient of 3 in front of my water, and that way I've got my oxygen is now balanced. From here, doesn't matter which I do next. I can do my aluminum or I can do my hydrogen. So if I do my aluminum first, I've got 2 aluminum in my reactant. Right now I'm only showing 1 of my products, so that means I need a coefficient of 2 in front of the aluminum. And now with my hydrogen, I've got 2 as my reactant, but when I've got that 3 coefficient, that means I've got 3 water, so that's 3 times 2, which means I've got a total of 6. So I'm going to need a 6 on my reaction side, but again, it comes in 2, so it means I need 3 pairs of hydrogens to get my balanced reaction. So for our second reaction here, I've got bromine liquid reacts with potassium iodide. So I'm looking at my element. This is a non-metal. So he is going to be making an anion. So that means he's going to be replacing the iodide ion in that compound. So that tells me that iodine is going to be the one he gets booted off by himself. So I'm going to have iodine all by himself. And iodine, again, he's one of those guys that comes in pairs, and he is a solid as an element. Now my potassium, he is that positive 1 ion. Bromine is a negative 1 ion. Crisscross to get my neutral compound. So that is 1 potassium cation and 1 bromide ion. I'm just going to erase my work there. Now I'm ready to do my balancing. So I typically like to balance. Actually, it doesn't really matter which way you balance first. So if I start going from left to right, I've got bromine. I've got 2 bromine here in my reactant side. I only have 1 on the product side. So that means I'm going to need a coefficient of 2 of the potassium bromide so that I can have that bromine balance out. Now when it comes to my potassium, I've got 1 potassium on the reactant side, but because I have 2 potassium bromides, that means I'm going to need to have that coefficient of 2 in front of potassium iodide to balance out my potassium. Now I've got 2 potassium iodide, so that means I've got 2 of the iodine. And when I look at my iodine on my product side, I've got 2 because it comes in pairs. So I now have that second reaction balanced. And let's do this last one that we've got here. So here I've got iron is reacting with hydrogen chloride. So I've got a metal reacting with a compound. And so because it's a metal, that means that it's going to replace the cation. So that tells me that hydrogen is going to be the guy who's off by himself. So I'm going to write hydrogen, and he's a gas. Now when it comes to iron, he's one of those multivalent ions. He's got the 3 positive ion, and he's got the 2 positive ion. I'm not told which one he's going to make, so I get to choose. And so the one that we're going to choose is the most stable ion, which in this case is the 3 positive ion. And how I know he's the most stable ion, because on my periodic table, that's the first ion that's listed. And then he's going to be paired up with the chloride ion. And when it comes to the chloride ion, he's that -1. So if I do my crisscross, I get 1 iron 3 ion, and I'll have 3 of the chloride ions. They'll make a solid. Now I need to balance. And so when it comes to balancing, if I look at my iron, I've got 1 iron at the reactant side, 1 iron on the product side. So iron is balanced. If I go to do my hydrogen, I've got 1 hydrogen on my reactant side. I've got 2 hydrogens on my product side. That's not balanced. So I need to have 2 hydrogen chlorides so I can get 2 hydrogen gas. So I'm going to put a 2 here in front of hydrogen. Now I'm ready to balance chlorine. So when I go to balance chlorine, on my reactant side for chlorine, I've got 2 of my chloride ions on my reactant side, but on my product side, I've got 3. And so I need to find what the lowest common multiple is between 2 and 3. And so my lowest common multiple between 2 and 3 is 6. So that means I'm going to need to have 6 chlorines on the reactant side and 6 chlorines on the product side. So I'm going to need to change this coefficient in front of my HCl, and I'm going to need to change it to 6. And because I've got 3 chlorines already in that compound, I'm going to need to multiply. I'm going to need to get 2 of the iron 3 chlorides. And so now I've got 6 chlorines on my reactant side, or 6 chlorines on my reactant side and 6 chlorines on my product side. So my chlorines are balanced, but my iron is not balanced anymore. So when I look at my iron, on the reactant side I have 1, but now I've got 2 on the product side, so that means I need a coefficient of 2 in front of my iron. And now I've got to double check hydrogen. Hydrogen, I've got 6. Hydrogen on my reactant product side, I only have 2. And what that means is I'm going to need to change the coefficient. So I need to get 6 hydrogens on my product side. So that means I'm going to need to have 3 of those hydrogen molecules to get 6. And now I've got that last equation balanced.